Imagine a civilization so advanced that planets are no longer enough. Its cities stretch across space. Its machines operate between worlds. And at the center of everything is a single source of almost unimaginable power: a star. Instead of allowing that energy to disappear into space, this civilization surrounds its sun with millions of machines designed to capture its light. Not one giant solid sphere, but an enormous swarm of collectors orbiting the star. Together, they could provide enough energy to power an entire solar system. This is the idea behind the Dyson Sphere. And if humanity ever hopes to become a Type 2 civilization, we may one day have to learn how to harness the power of our own sun. But could something this enormous ever actually be built? Human civilization has always been shaped by energy. At first, there was fire. Then came wind, water, and animal power. Later, coal transformed factories. Oil reshaped transportation. Electricity illuminated cities and connected the modern world. With every technological leap, our demand for energy increased. Today, almost everything we depend on, from transportation and industry to communication networks and data centers, requires a constant supply of power. And that demand will not stop growing. If humanity expands beyond Earth, builds permanent settlements on other worlds, and creates industries across the solar system, our energy needs could eventually exceed anything our planet can easily provide. And that is when one source of power becomes impossible to ignore: the sun. Earth has given humanity everything: air, water, resources, and the energy that allowed civilization to grow. But a single planet has limits. As populations expand, industries grow, and technology becomes more demanding, civilization may eventually need resources and energy far beyond what one world can easily provide. A future spread across the Moon, Mars, asteroids, and orbital habitats would require power on a completely different scale. Factories would operate in space. Cities would exist beyond Earth. Entire populations might depend on artificial environments. At that point, the question changes. It is no longer how much energy one planet can produce. It is how much energy an entire civilization can access. And beyond Earth, the solar system offers something far greater. From Earth, the sun feels familiar, but up close, it is almost beyond comprehension. At its core, nuclear fusion releases enormous amounts of energy every second. That energy travels outward through the star, then escapes into space in every direction. Only a tiny fraction reaches Earth. Yet even that small amount is enough to warm our planet, drive the climate, and support nearly all life. Most of the sun's energy never touches a planet at all. It simply continues into deep space. For us, that power is mostly unreachable. But for a civilization advanced enough to build throughout an entire solar system, the sun would represent something extraordinary. Not just a star, but the largest energy source within reach. In 1960, physicist Freeman Dyson proposed a remarkable possibility. If an advanced civilization continued to grow, its demand for energy might eventually become so great that it would begin capturing a significant fraction of the power produced by its own star. To do that, it could construct enormous numbers of artificial structures in orbit: solar collectors, habitats, factories, perhaps even vast computing systems. Over time, these structures could spread throughout the star system, intercepting more and more of the star's light. The idea became famous as the Dyson Sphere. But despite the name, Dyson was not simply imagining one giant solid shell. The real concept was much broader. A civilization, slowly surrounding its star with technology. When most people hear the words Dyson Sphere, they imagine a gigantic solid shell completely enclosing a star. It is a powerful image, but it is probably not the most practical version of the idea. A rigid shell would require an extraordinary amount of material. It would also face enormous structural and orbital challenges. A Dyson swarm is very different. Instead of one solid structure, imagine millions of independent collectors, habitats, and stations orbiting the star. Each object follows its own path. Each captures part of the star's energy, and together they function as one enormous system. The swarm can grow gradually, one structure at a time. That makes it far more flexible and far more plausible as a path towards stellar-scale civilization. Building millions of structures around the sun would require an enormous amount of material. Launching everything from Earth would be far too difficult. But the solar system is filled with resources. Asteroids contain vast quantities of metals, the moon offers rock and minerals, and Mercury, orbiting close to the sun, could provide both raw material and abundant solar energy. An advanced civilization might send autonomous machines to mine these worlds. Robotic systems could extract resources, refine them in space, and transport them directly to orbital factories. Instead of treating planets and asteroids only as destinations, a stellar civilization might see them as the building blocks of something much larger: the raw material of a Dyson swarm. Once the resources are available, construction could begin. At first, only a few orbital factories might exist. They would manufacture simple solar collectors, launching them into carefully planned orbits around the sun. But automation could change everything. Machines could build more machines. Factories could produce new factories. And every new collector would provide more energy for further expansion. Over time, the process could accelerate. Hundreds of collectors become thousands. Thousands become millions. The Dyson swarm would not appear overnight. It would grow gradually, layer by layer, generation after generation, until an entire civilization had transformed the space around its star into one vast industrial ecosystem. As the Dyson swarm grows, the solar system itself begins to change. Energy becomes abundant. Industry moves away from planetary surfaces. Factories operate in orbit. Asteroids become sources of raw material. And enormous habitats appear throughout space. Civilization is no longer centered on Earth alone. Mars, the moon, orbital colonies, and distant stations become part of one connected system. Planets remain important, but but space between them is no longer empty. It becomes infrastructure, transportation, industry, and home. For the first time in its history, humanity would no longer be a species living on one world. It would become a civilization spread across an entire solar system. For a Type 2 civilization, life may no longer revolve around planets. Millions of people could live inside enormous rotating habitats. Artificial worlds could contain forests, oceans, cities, and farmland, all floating in space. Energy from the sun could power industries on a scale we can barely imagine. Computers could process unimaginable amounts of information. Factories could operate continuously across the solar system, and new living space could be built whenever it was needed. Earth might still remain important, perhaps as a protected world, or simply as the birthplace of humanity. But for future generations, home may no longer mean one planet. Home could mean an entire solar system. A Dyson Swarm would offer extraordinary power, but it would also create extraordinary problems. Millions of structures would move through space at enormous speeds. A single collision could scatter dangerous debris across entire orbital regions. Then there is heat. Every machine that uses energy eventually produces waste heat that must be released into space. Communication would also become difficult. Across a solar system, even light takes time to travel. No single control center could manage everything instantly. Habitats and factories would need to become increasingly autonomous. And perhaps the greatest challenge would not be engineering at all. It would be coordination. Because building a Type 2 civilization may require humanity to master more than energy. It may require us to master complexity itself. If another civilization has already built a Dyson Swarm, we may never see its cities or spacecraft directly. But a civilization operating on the scale of a star could leave clues. A Dyson Swarm would block part of its star's visible light, and after using that captured energy, the civilization would eventually release some of it as waste heat. From Earth, astronomers might detect something unusual. A star that appears dimmer than expected, irregular changes in brightness, or an unexpected excess of infrared radiation. These are known as technosignatures, possible signs that technology has changed the appearance of a star system. So far, no Dyson Swarm has ever been confirmed. But somewhere among the billions of stars in our galaxy, there may be systems that deserve a much closer look. And this leads to a disturbing question. If advanced civilizations are possible, where is everyone? The Milky Way contains hundreds of billions of stars. Many are far older than our sun. If intelligent civilizations are common, some may have had millions of years to expand, build megastructures, and perhaps even surround their stars. Yet we have found no confirmed evidence of a Type 2 civilization. Maybe intelligent life is extremely rare. Maybe civilizations destroy themselves before reaching this level. Or perhaps advanced societies use technologies we do not know how to recognize. The galaxy may not truly be silent. We may simply be listening in the wrong way. But until we find something unmistakable, the mystery remains. Today, humanity is nowhere close to building a Dyson Swarm. But every extraordinary journey begins with smaller steps. Permanent settlements on the moon, factories in orbit, mining asteroids, building habitats beyond Earth. One achievement could make the next possible. And over centuries, or perhaps millennia, human civilization might slowly expand until the solar system itself becomes our home. No one knows whether we will ever reach Type 2. Perhaps the challenges will be too great. Perhaps our future will take a path we cannot yet imagine. But if humanity ever succeeds in mastering the energy of the sun, one frontier will still remain. Because beyond our solar system, billions of other stars are waiting. And eventually, we may ask an even greater question. How do we reach them?